Okay, so welcome to this live chat. We've been waiting for people to log in. So I've been seeing how many people have logged in. So since we are now having a couple of people, I think people will join in. So I think we'll get started slowly. I'm just trying to read from questions that were posted on the form, Google form, right? So the first question is from Chitra. I think she's not there, but that's okay. I will still answer her. The question is regarding expertise in novice task. Can you comment on the role of engrams? I think she is saying she is meaning engrams in the sense that Bernstein's engrams. I think, or maybe she is meaning engrams. The word engrams in the. Let me type so everybody is clear what that is. Engrams. I think maybe she is meaning them in the sense that these are motor programs, I suppose. The question is what happens with expertise, or what happens with experts and novices, or how do these things change? So essentially, when you are a novice in a motor task, what happens is that your goal is to somehow accomplish the task. So the engram there, or the motor program there, is relatively, I would say, not optimized and is probably open to editing, or in other words, is flexible to be optimized, right? So, but as you go along after some time, what happens is as you reach expertise, this program becomes uh, a lot less editable, or depending on what stage of expertise you are in. A really good example that I like to give is this example of the backward bicycle, right? So in the case of the backward bicycle, you could just YouTube for that. The backward bicycle is this case where when you turn the handlebar to the right, the bicycle will turn left, and when you turn the handlebar to the left, the bicycle will turn right. Now, in that case, what will happen is if you are using a person who is who has practiced bicycling for a long time, for several years, now if you ask him to ride the backward bicycle, usually they can't even ride it for 10 seconds. This is because this engram, or this motor program, is crystallized, is at a stage where it is stored in relatively permanent memory. Again, it's not clear what these things mean. So several of these things are poorly defined. I'm using these terms without defining them really well, but what I mean is that it's really tough to edit that program. It turns out that you can still edit it. It's tough, but it's possible. People have done this, people have practiced this for several months. After several months of practice, people can ride the backward bicycle. Now, that means this program, or this engram, has been taken out from its permanent memory, then edited, and then actually, you know, used to ride the backward bicycle in this case. It's a very, let's remember that this is a very tough biomechanical task because it's a whole body action. Bicycling, although it is the leg that is riding and it is the hand that is directing, but balance in bicycling is coming through whole body action. It's a whole body exercise. And several postural muscles are simultaneously active to keep the body in equilibrium. So when you are learning to bicycle, or when you are unlearning and relearning a new bicycle riding mode, for example the backward bicycle, you're essentially taking out a relatively crystallized motor program, or an engram, and then editing it and then putting it back into its library, sort of library. So I hope this kind of answers her question, Chitra's question. But I actually didn't understand what she meant by engrams, so I answered it in the sense that I understood it from my point of view. We know engrams as motor programs. Again, that's a very tricky term. Motor program, engrams are all terms that have that come with some baggage, right? Terms that have certain implications that are probably not accepted by all. Okay, but with that caveat, I think we'll stop answering that question. But are there any questions from you? Then I will take the other questions. I have a couple of more questions, but other questions from others here. So there are a few more people now. Gautam, Indu, and a few others. Are there any questions? By the way, thank you so much for all the people who registered for the exam, and I appreciate you taking the time. Now, it's not just about registering and making the payment, it's about making your money count, it's about making your time count. After all, you've invested so many hours into watching these videos and reading the book and, reading other materials. And also, maybe you also paid 1,100 rupees. It's not about doing these things, it's about making it count. I think you should keep pushing yourself. I encourage you to stay on with the course. I know this is a relatively tough course to stay on, but all good things, right, worth having, come after some tough or hard work. So I encourage you to stay on in the course, and in the end, you will have some uh, an accomplishment that you will find really rewarding. You will feel rewarded at the end of the course, I hope. And are there any questions? Gautam and Indu. Okay. Um, well, in that case, let me go to the second question, which is I think I'll go to the third question by Jayavel Sundaramurthy. Is he here? Jayavel? Jayavel, are you online? Okay. Jayavel is not there, but that's okay. I'm going to still uh, try to read and try to answer that question. I actually don't know the answer to his question, but I'll anyway read it and try to make an attempt to answer that question. The question is, what would be the advantage of neural processing of information in the contralateral brain? Now, that's a that's a complicated. That's a controversial question. So the question is, why are the right hand? Why is the right hand controlled by the left side of the brain, and why is the left side or the left hand, or the left side of the body controlled by the right side of the brain? What is the advantage? So I think the question is again, what is the evolutionary advantage? Right? So when he is asking what is the advantage, I think he is talking about what is the evolutionary advantage. This is being discussed elsewhere. This is being discussed from time to time. I think the advantage, for example, well, to start with, uh, this is probably a human thing, probably not there in other animals. Why? We'll start out with that. Now, when the human hands became free, in other words, when humans started walking upright, right, the hands became free. Then that gave rise to the option for humans to eat or to find food and get food and eat in ways other than the ways they were earlier used to. So in other words, they could forage for food. So the hands became free, and you could forage for food, and that also meant that you could there is a unique advantage enjoyed by the humans when compared with other animals. When they are standing upright, they could see farther when compared with other animals and identify an approaching predator. So essentially, the hands being freed uh, served as an important um, milestone, evolutionary milestone. Right? So then, what happens after the hands became free? There is a there is development of communication. So these areas that are responsible for language, for example, are localized in one side of the body, one side of the brain. Right? So that means that uh, once again, that means that language again is a uniquely human thing. Right? So, but that requires a substantial amount of neural processing. Right? So language and language related activities. So in terms of, well, now we have very well developed and structured language. We do not know what the language was when the first languages were developing or were developed, but the point is that it did require a substantial amount of structure and correctness and planning. So this probably might have led to a situation when where different hands or the other side, the contralateral side, might have been required to have been controlled by the other side. Once again, it's not true that the 100% of the neurons from one side project to the other side. If you had seen the videos carefully, you would have realized that only about 85 to 90% of the neurons project contralaterally. The remaining projections are actually ipsilateral. They project to the same side of the body. All right. So uh, probably it is hand function, probably it is language, probably it is those things. However however I actually don't know what is the unique evolutionary advantage. I'm not able to say what the unique evolutionary advantage of using the contralateral brain to control the other side of the body. Right. So that's that. Mm. Are there any other questions? Right. Just waiting for questions from Indu and Gautam. Apparently, they are the only active ones here now. Few more people have logged in, I think. Indu, did you have any questions? Gautam is having a question. Can you share your ideas on neuroimaging techniques? Okay. Neuroimaging comes in various flavors. Okay, the two popular flavors, right, those that are used in research. The two popular ones. Excuse me. The two popular ones are fMRI, or functional magnetic resonance imaging, and fNIRS, or functional near infrared spectroscopy. Okay, one uses magnetic or magnetism as the principle, the other uses optic principles. Important to note is that fMRI can measure uh, activity and in tissues that are deep below the cranium, below the skull, whereas NIRS can measure up to 10 from the surface of the cortex. That's actually an optimistic estimate. It actually measures much less. Okay. Now, what do these things even represent? First of all, what is measured by these things? right? Usually, essentially, fMRI measures the blood oxygenation levels. So if a particular area in the brain is active, then it receives more oxygen, right? So that means the blood oxygenation level in that region of the brain will be higher. So this is used to quantify activity in a particular area of the brain. The advantage, well, the advantage is that it's non-invasive and it can be performed without hurting anybody, and it is actually in it is actually can be considered to be an analog of recording from the brain. But the disadvantage is that it's not an exact analog of the neural recordings or microelectrode recordings that we have from animal models. Why? Because in this case, you are essentially capturing a secondary signal. You are capturing something else. You are capturing the blood oxygenation level. Right? Usually, this is a popular method. So you are capturing the blood oxygenation level, and the blood oxygenation level might not be so quickly responsive. That is one, and might not have the resolution that you want. So essentially, fMRI suffers from problems of poor resolution, right? So this is a huge problem, right? So, and NIRS, for example, also the advantage with NIRS is that you don't need to be inside a closed chamber like uh, in the case of an MRI, right? In the case of fMRI, you may have some sort of claustrophobia, right? That problem is not there in the case of FNIRS or F or functional near infrared spectroscopy, right? In that case, you don't have that problem because this system can be used just like EEG. The disadvantage is that it doesn't measure deep enough. The other disadvantage of the fMRI also is present here. Here also you don't have a good temporal resolution. So what is the system that's probably going to give me both spatial and temporal resolution? It turns out that if you combine EEG measurements with FNIRS measurements, for example, then it's possible um, for you to get relatively accurate and both temporal and spatial resolution, right? So that's one approach that is being increasingly used to get both temporal and spatial resolution, combining EEG and functional near infrared spectroscopy. That's one. This is relatively less expensive. Of course, the gold standard when it comes to this is, of course, what is called as MEG or magnetoencephalography. So that is very expensive and is considered the gold standard. It provides both temporal resolution and spatial resolution, right? So essentially, neuroimaging can be classified into this. Then there is this new idea of using multi-channel or a large number of channels of EEG and trying to do some sort of tomography sort of analysis using EEG data. Well, then in those cases, what happens is there can be an image that can be created in terms of activity level at a given point in time using EEG data, EEG activity. Now, that can be used to analyze using regular image processing type of analysis. Now, that's not exactly an image, that's still EEG activity at multiple sites, but still, since you are having too many such data points, or in other words, depending on how many electrodes you have, in some cases it can be as high as 256. So if you are having 256 channels, then you will get a relatively high uh, spatial resolution from which you could construct an image and then process that image, right? So that's the other approach. That's not neuroimaging, but people are getting excited about this kind of approach, which is multi-channel EEG being considered to be equivalent to neuroimaging, right? So these are the various things. So essentially it's fMRI, FNARS, MEG, and 200 channel or 256 channel EEG or 128 channel EEG type. Okay. So I hope I answered that question, Gautam. All right. Mm, are there any other questions before I move on? Because there's a huge question from Anusha. I don't know if she's online. Okay. Okay. Thank you, Gautam. You're welcome. Okay. I will start answering the questions from Anusha because she's asking. The fifth assignment questions are a bit tricky. Can you please explain them? Uh, it's a bit tricky for all of us, so I will try to um, go through them one by one. All right. Are there any questions before I proceed with the fifth assignment and explaining the fifth assignment? I hope no. So I'll try to proceed. Right. Okay. How to share the screen? Okay. Is this visible to all of you? I'm sharing assignment 5. Is it visible? Yeah. Okay. Assignment 5 is now visible. The question is we'll go one by one. Okay. This is my own login. I have um, I have logged in as a student with my personal ID, and of course I'm not submitting the assignments. The question is in the tonic stretch reflex characteristic, the part with the low slope value is due to the passive elasticity of the muscle. True or false? The answer is true because if you see, let me try to open Windows journal and show you. So if you see the tonic stretch reflex characteristic, initially it will be like this, and then you go like that, right? So that part is the part with relatively low slope. This is the threshold of the tonic stretch reflex, or what is called as lambda. Right? So that happens, or the area with low slope or the region with low slope is happening because of the passive elasticity of the muscle. So the answer is actually true. Okay. Now question 2 is Renshaw cells excites the antagonist alpha motor neurons by which one of the two? Right. So Renshaw cells, let's remind ourselves of what these cells do. Renshaw cells are those inhibitory interneurons that are getting excited by the alpha motor neurons, and they in turn inhibit the alpha motor neuronal pool of all the synergists and the gamma motor neuronal pool of all the synergists, right? And they also inhibit the 1A interneuron of the antagonist. Let us remember what this means. So, Renshaw cells are activated whenever the muscle is contracting or when the command to contract the muscle is given. Is it not? So, when you are saying that you want to have some sort of negative feedback, so one way to do that is to reduce the activation level by directly inhibiting the alpha motor neurons. The other way is to actually kind of encourage the opponent or the antagonist to excite itself. So if the antagonist is excited, that is in a way providing some sort of balance to the activation of the agonist, is it not? So but the 1A interneuron of the antagonist is inhibiting the antagonist, and if the 1A interneuron itself is inhibited or in some sort of disinhibition is done, then you will essentially have, or the probability of the antagonist getting excited will actually be higher. Because of this reason, the Renshaw cells actually excites the antagonist. Excites means what? Or increases the probability of excitation of the antagonist alpha motor neurons by the inhibition of the 1A interneuron and disinhibition. Okay, so that won't happen. So these two. So both A and B are the answers. Okay. Now, for the third question. Under physiological conditions, all of the following mechanisms participate in the regulation of skeletal muscle contractile force, except, please read the questions carefully. The question says, except one, what are the things that are participating, right? So, which is the one that is not participating is the question. So, skeletal muscle contractile force is the one that needs to be regulated, which is the one that is not playing a role in this regulation is the question. First, frequency of action potential firing, motor neurons innervating the muscle, right? Two is the recruitment of active motor neurons innervating the muscle. Three is the length of individual muscle fibers that are activated in the muscle. Four is the amount of neurotransmitter, the number of neurotransmitter released at the neuromuscular junction during each action potential, right? So it turns out that the first two are obviously the first two refer to rate coding and size principle. Obviously, they play an important role in regulating the skeletal muscle force. But what about the third one? The length of individual muscle fibers. Obviously, as the length changes, the force will change. There is a definite length force relationship in the case of muscle fiber. This is probably not discussed as part of this course, but it is there, right? Then you could, but the number of neurotransmitter molecules that are getting released actually cannot be controlled, cannot be regulated using simple methods, right? So because of this reason, again the question is under physiological conditions, right? So because of this reason, the answer is actually D, the number of neurotransmitter released at the neuromuscular junction release, during each action potential. All right. The question. And excuse me, I'll go to the fourth question. Projections from afferents within a muscle to motor neurons controlling the same muscles is called. So this is homonymous projection, or this is also called as autogenic projections, right? From within a muscle to motor neurons controlling the same muscle, like in the case of Renshaw cells. But this kind of projections are called as autogenic. They are not called Renshaw cells. Renshaw cell is a type of neuron, but this type of projection is called as autogenic projections. Okay. Question 5 is the feedback given by Renshaw cells to 1A interneurons is positive. Now, Renshaw cells are inhibitory interneurons, right? So they inhibit. The feedback given is actually not positive, but rather negative, because these are inhibitory interneurons. So the answer is false. Okay. Question 6. The output of alpha motor neurons excites which of the following cells? Obviously, Renshaw cell is one of the one that is getting excited by that. Is the answer there? The answer is yes. So that is the answer. Okay. And the next question is reflex latency depends on. What are the various things that the reflex latency depends on? First is how much time is taken for the sensory conduction to happen, or the time taken for afferent conduction, the time taken for efferent conduction, and, and the amount of time that is spent in the central processing unit or the central delay. So essentially the answer is A, B, and C. So all these three are the correct answers. Oh, let's go to the next question. How does the magnitude of H reflex respond when the stimulus strength increases? It's very important to realize this. H reflex magnitude, right? H reflex magnitude means this is a reflex with one synapse at the central, or in other words, there is only one central synapse. Is it not? Now, the its properties or its response to stimulus strength will depend on the nature of the synapses that it shares, is it not? So what will first happen is that as I keep increasing the stimulus strength, the H reflex magnitude keeps increasing. Why? Because the more and more 1A afferents are getting recruited. Please, let's remember what's the physiological mechanism by which this happens, right? The response, whenever we say response, we are essentially meaning um, we are essentially talking about an EMG response. Okay, so when I say response, that is the net response of the entire muscle measured at the level of the muscle. So that's EMG response. And as I keep increasing the stimulus strength, then what happens is the number of 1A afferents that get recruited excuse me, the number of 1A afferents that get recruited increases, and more response from the central to alpha motor neurons increases, thus increasing the overall response. So this happens in the initial stage. As this continues, after some time, what happens is that the role of, or the critical role of the refractory periods come into the picture, is it not? You can't keep firing, you can't keep increasing the amplitude forever, because at some point what will happen is that as the amplitude keeps increasing, it is not possible for recruiting any more alpha motor neurons, the because of the refractory period, right? So then from that point onwards, there will be a decrease. Because of this reason, you will have a non-monotonic response in the you will have a non-monotonic response like that for H reflex, whereas for M response you will have something like that. That's not actually, that's not that. Initially there will be no M response, and then it starts, and then it goes, and then it goes, something like that. This is M and this is H reflex, right? Something that we have seen. These are questions that I love to ask, and these are answers that I love to discuss. So yeah. Then the next question is I think we missed this. Okay. Yeah, so the H reflex response, to complete the previous question, the H reflex response initially increases and then decreases. All right. Okay. Then what happens to the when a stimulus is applied to a muscle nerve? The magnitude of depolarization in the individual fibers depends on which of the following factors is the question. The answer is all. Actually, the answer is all of the above. So because thickness affects conduction, location of the fiber, whether it is superficial or whether it is deep affects the conduction, and the number of sodium channels affects the conduction. So yeah, the next question is by the 10th question. By applying high amplitude of electrical stimulus, what happens to M response and H reflex? Right. This we saw earlier, is it not? M response increases and then H reflex decreases. I already described what happens here. Uh, just a few seconds ago, just a few minutes ago, we showed here. As the this is okay, we have not written the. This is the amplitude of the stimulus. This is the amplitude of the response. So as the stimulus amplitude increases, initially the H reflex amplitude increases but then decreases. The M response amplitude increases and then settles at a or flattens out. Right. Question number 11. When two signals arrive at a target alpha motor neuron simultaneously, what will happen? Well, depending on the phase, it's possible that they will extinguish each other. Okay, but if they are arriving simultaneously, they will extinguish each other. Okay. Question number 12. By applying successive stimuli at high frequency, what happens to M response and H reflex? Let's remember this again. Will not change the M response. Why? Because M response is the muscle's response, is it not? M response doesn't have any central synapse. There is no possibility for the M response amplitude to go down because of any kind of refractory period or anything. But H reflex involves at least one central synapse, is it not? That's what we saw. H reflex involves one central synapse, and that means it's possible that depending on the refractory period, it's possible for the H reflex amplitude to decrease. So essentially, increasing the stimulus frequency will lead to a situation when the M response will remain the same, but H reflex amplitude will decrease. Okay. Actually, an interesting question is, what should I do to reduce the M response amplitude? Can I do something to reduce the M response amplitude? The answer is yes. If the stimulus frequency is high enough that the M response or the conduction of M response itself faces refractory periods in terms of sodium channels near the point of stimulation going through a refractory period, then yes. But for that to happen, you need to have a relatively high frequency. But the question is, what is that frequency? Okay. And that must be high enough depending on where you are stimulating. Okay. So it is possible, but this is this is happening at a very high frequency. So but as the frequency is increased, essentially the H reflex amplitude will decrease. This is the key point that we want you to learn. Okay. Now the next question is the response that does not decrease with stronger stimulation and increase in the stimulation frequency is. Actually, this is an interesting question because excuse me, this is its amplitude does not decrease with stimulation, but and its amplitude increases with increase in frequency of stimulation. Now if now if you say H reflex, its amplitude decreases with stronger stimulation. This is done. That's also true with T reflex. Well, T reflex is essentially the mechanical analog of the H reflex. Now, both H and T are similar, so they are going to respond similarly. Now, let's take M response. The case of M response. In the case of M response, the response does not decrease with stronger stimulation. It also does not increase with stimulation frequency. But in the case of F wave, this will increase with the stimulation frequency, because F wave is this wave that involves the alpha motor neurons backfiring. So this is the wave that travels from the site of stimulation to the alpha motor neuronal soma cell body, and fires back an action potential that then results in a contraction that is then observed as a response, right? Now that will depend obviously on the frequency of firing, is it not? So because that involves, although it doesn't exactly involve synapse, but it does involve the channels in the alpha motor neuronal in the alpha motor neuronal cell body, and so the response will be affected by the phase at which it is coming, or the frequency at which it is coming. So essentially the answer is F wave. Okay, for this, are there any questions? Because there are, okay, I'll finish these two questions. There are only two more questions, and then we'll discuss the rest. Question 14. Renshaw cell connection with 1A inhibitory interneuron causes A. Inhibition of antagonistic motor neuron, inhibition of agonist motor neuron, inhibition of 1A interneuron, and D is both A and B. Actually, what happens is Renshaw cell connection with 1A inhibitory interneuron will cause the inhibition of 1A interneuron. Is it not? Which 1A interneuron? This is the 1A interneuron of the antagonist, and that essentially means the inhibition provided to the antagonist motor neurons is reduced. Okay, so of course there is an independent action of Renshaw cell directly by through their synapse with the alpha motor neurons, that is the inhibition of agonist motor neurons, but that's not counted here, because we are talking about what happens with 1A interneuron. Okay. Question 15 is T reflex is due to shortening of muscle, while H reflex is due to muscle lengthening. Well, this is false, because T reflex and H reflex are both the same, except that H reflex involves electrical stimulation, whereas T reflex involves mechanical perturbation. So these are essentially the same thing. Okay, T reflex is the mechanical analog of the H reflex. Okay, or the other way of saying it is H reflex is the electrical analog of the T reflex. Okay, so the answer is false. Okay, are there any other questions here? There are only like 6 or 7 of us, only a few of us, but are there questions? Okay, there are 8 of us now. There is the question from Aquarian that I don't understand, of course. Is there any health effect of gadolinium contrast? I don't know what that means. I'm not able to understand what is a gadolinium contrast. And MOOC training is saying, hello MOOC training, how are you? All right, so I have answered all the questions in the form. That is the question by Chitra, Anusha, and Jaivel. And with that, I think I will yes, then. Okay, MOOC's training is asking something. Shall we get access to the PPTs used by you during the classes? This will help us to revise the subject. The answer is no. No, actually, I am very open minded about this, but the kind of horror stories we hear about um, the PPTs and the questions being used and databases being created, um, we would I would like to be a little cautious about this in terms of sharing material, because again, that I would love to share material with students. My students know me. My students who have with whom I have interacted and who have listened to my class know that I'm absolutely open minded about sharing material. But it's becoming increasingly difficult to prevent misuse or abuse of these materials. So at this time, I'm not having any plan of sharing PPTs or the questions, or anything else. So yeah, but there is a plan, of course, to share class notes or lecture notes. um, so lecture notes means essentially the trans transliteration, essentially the typed out content that are spoken in class. So so there is a plan to do that. I don't know when that will happen, though. I have no clear plan for that. Yes, that plan is there. I don't know the clear timeline for that. I have not been following up very eagerly on that, because getting the videos up and going and following up with the course material and content itself has been a bit of a task for me. I've been completely occupied doing these things. It's consuming a tremendous amount of time. I haven't been able to follow up about the getting the lecture notes ready. At some point it must be ready, although I don't know when. So I'm not able to commit to a timeline for that. um, so again, regarding PPT sharing, it's possible for us to share the PDFs. um, Note that since the content is going to go online using CC BY license, we have put in a tremendous amount of effort in preparing the diagrams, figures, and the PPTs. I don't know if you are able to see that. Actually, the amount of effort that has gone into preparing off the slides and preparing off the pictures and the images. Actually, these images are not stolen from the internet. Any brain image that you see in my course are all hand drawn by specific individuals. One thing is that we spent a tremendous amount of money getting this done, but it's not about money. The amount of time and effort that went into preparation of this material is humongous. Again, that doesn't mean that we shouldn't give it out. We want to give it out to the right people. We want to give it out to the students. And at this time, we are having great difficulty in identifying who are these right people, and uh, who are unscrupulous people who want to misuse it, because there are websites that just come up where databases of all the assignments and all the PPTs and all the questions and all the answers, all the exam questions are all available for each course. Apparently, I am actually not aware of what these websites are, but apparently these things are available. And our goal here is to teach students to learn and become responsible citizens. If we by mistake share this with unscrupulous people, then it actually has the opposite effect. Then what am I doing? So that's the question. So yeah, lots of philosophical questions, lots of this. So yeah, lecture notes, I will try to see, mm, although not able to commit to a timeline now. Excuse me. Aquarian's question about contrast in MRI. Yes, contrast in MRI is one method to improve the specificity, the fineness of the image that you get. But I am not aware of this particular contrast. By the way, I am not a neuroimaging person, so I have very limited understanding of MRI and how it works. So yeah, I don't know about this particular contrast. But what I do know is that there are specific contrasts for specific purposes that are available. So to that extent, yeah, that's the answers. Are there any other question? There are a few others. who are logged in, but they are just hiding and listening to others speak. We have a couple of minutes before we wind up. Oh, I realize Aquarian's question is there going to be any health effect? Okay. The question is there going to be any health effect of or the side? I think the question is there any side effect of the contrast? Yeah, she's answering that. Okay. Um, well, whatever side effect that is going to be there, it's going to be there only temporarily, right? So it's not going to be absorbed by the system. The system is going to put in a lot of effort to try and flush it out, right? Okay. So that's the question. Gadolinium contrast causes nausea and vomiting, headache, itching, flushing, mild rash and hives. It's highly immunogenic and often causes allergic reactions. Again, this there are just so many of these contrasts, and different contrasts have different effects. But again, what Srinidhi is saying um, probably is not true for every case. So again, some of the side effects, I hope, I suppose, one has to read about that. MOOCs training, what is the advantage of information processing in the contralateral side of the brain? I already answered that question. So essentially, probably it is having an evolutionary effect due to language development. Again, there isn't a particular answer to that question. I mean, it's a philosophical question. So I'm trying to answer to whatever. I have no idea what Aquarian is asking. German scientists have found that nerves transmit sound signal instead of electrical impulse. How true is this? I don't know. I don't know what exactly is the question. I'm not able to understand. Sound signal means, are you saying signals from the auditory system being carried? That's also electrical. Everything is electrical. Electrical means what? Ionic. Regular thing. All right. So, well, uh, if there are no other questions, I'll wait for some more time if there are any other questions. So, we got a few questions, like two, three questions. And after that, we have not been having too many questions. So, the question is, yeah, the question is, yes, hertz instead of amperes. Yeah, hertz instead of amperes. I have no idea what this is. Is that even amperes? Okay. Um, I'm not able to understand that particular question. All right. I think I will go back to the this and stop the screen share. Stop screen share. Okay. So it's about time. Um, it's about an hour since we started, and I think we should call it a day. Thanks for your interest. We had quite a few people joining in, and quite a few of us, quite a lot of us, quite a lot of students have registered for the exam. I'm proud of that. I'm very happy about that. But let me remind you, it's not about registering for the exam. You should actually take it. It's not just about taking the exam just because you have registered for it. It's about, you know, committing, making a commitment and keeping that commitment. You have made the commitment. Those who have registered for the exam, you have made that commitment. But keeping that commitment requires continued and persistent effort from all of you. I hope you will continue to invest your time and energy into this course so you can get the maximum out of this. So keep your feedback coming. I'll keep working with you. So thank you very much for your attention and your presence in today's discussion. I hope to have one more of this before the course ends, although I'm not able to say when. Most likely in the second week of, as in after the second week of October, like more like the third week of October sometime. Okay. Thank you very much for your attention and thanks for joining us. Have a great evening. Have a great Sunday.